All right, today we're just adding a layer onto what we've been doing with contingency tables and Venn diagrams. So we're going to see examples where we don't just have two overlapping events, we might have three. So first I'm going to start us off with a little review. Here, our situation, we have Alex. Alex loves films. He has 250 films in his collection. He owns 27 James Bond films. He owns 25 films that star actor Daniel Craig. In his collection, there are 47 films that are James Bond films or star Daniel Craig. If he picks one at random to watch, we want to calculate each probability. So we know that event J means it's a James Bond film. D, we know that it's going to star Daniel Craig. So first thing that I'd probably label is down here for my Venn diagram. I like a good visual. So I know that there's 250 films total in Alex's collection. Okay, we're told that he owns 27 James Bond films. So this circle has to sum to 27. 25 films that star Daniel Craig. So this circle has to sum to 25. And we're told that there are 47 films that are James Bond or star Daniel Craig. So we know that these three portions together have to sum up to 47. So if I first want to find that intersection region right here, I would look at James Bond, Daniel Craig, right? If my events were mutually exclusive, I could add those together and it would make up the number right here. But since it's inclusive, there's overlap, I can get to that overlap region right here by adding the 27 to the 25 and taking away the 47. Okay, so here I have 52, take away 47, I get 5. So my overlap, right, the intersection is 5 right here. So then, since we have 27 with James Bond, we're just taking 27, take away 5, and we get 22 in this region. We have 25 that star Daniel Craig, right? We're told that right here. So 25 minus 5 gets me a 20 right here. So what that's showing me right now is that there are 5 films that are James Bond starring Daniel Craig, 22 that are just James Bond, right, do not star Daniel Craig, and then 20 films that star Daniel Craig but are not James Bond. And if I add those up really quickly, that sums to the 47 that is my or, right? It could be either or. It could be one of these things or both of them. So now I always like to calculate this space over here as well. It's my leftover. It's the no to both things. So if I take my 250 total and I subtract that 22, the 5, and the 20, I end up with 203 in this space out here. Okay, so I've allocated all of my values to my Venn diagram, and now I'm just calculating these probabilities. So probability, it's a James Bond film. Well, 27 total, right, out of those 250 total films. So I'm taking my total for James Bond, I can take it here, or I can add up everything in this circle right here, 27. It does not reduce. Okay, here next, the complement of starring Daniel Craig. So here I can say, well, it's nothing in this circle here. So I could add up those two figures that remain, or I could do 1 minus the probability that the film does star Daniel Craig. I'd probably do it that way. So 1 minus the 25 over 250, reduce it down, it's going to be 9/10. Okay, next, here it's saying James Bond or Daniel Craig. So we're saying it could be either one of these things. We already were given that in our setup. We know it's the 47 out of 250. And I can double check it, right? Again, I can double check it. If I add the 22, the 5, and the 20, it gets me back to that 27 right here. Here now I see intersection. So I'm saying where did they overlap? That was the 5 that we calculated initially. So we're looking at 5 over 250, and then reducing it down to 1 over 50. So I showed you that fancy shortcut, how to do math frac in your calculator. A little reminder, right? If I type in 5 divided by 250 and I hit enter, right? I see it as a decimal. I hit math arrow to fraction, convert it to a fraction, and it's nicely reduced 1 over 50. So we have that beautiful shortcut available to us. Okay, next we're looking at where is it? It's not James Bond, so it's nothing here, right? So we're looking at what remains, and where does that overlap with it being Daniel Craig? Well, I can block this out of view. It's right there, that little reverse crescent moon shape, that 20 out of 250. Reduce this down to 2 out of 25. Okay, and then lastly, another intersection where it's saying not James Bond. So here, where does that overlap with it being not Daniel Craig? So I'm blocking those out of view. My leftovers where I'm saying no to both things of interest, that's my 203 out of 250. Does not reduce. Okay, so a good review when we have two events that we're interested in any overlapping parts, right? The intersection and the union. Also seeing the formal notation. So now we're going to extend that and look at, well, what happens when we have 3 different events? Slide that up to here. Okay, so here we have a Venn diagram. It shows students in a 5th grade class who study music, French, and art after school. If one student is selected at random, calculate each probability and shade the appropriate part of the Venn diagram. So I have a colored pencil out ready to go. So here, first off, I'm not given a grand total, so I'm going to just add these up. I'm going to add the 4, 2, 1, 3, 3, 1, 1, and the 6, and see that, oh, we have 21 total students. Okay, so when we're looking at how these circles intersect, right in here in the center, that's the overlap of all 3 things. So this one individual studies music, French, and art after school. Okay, anything here, for example, this would be individuals who study music and French after school. Over here would be art and French. Here would be music and art. Okay, anything here, right, these 3 only study French. It's the only thing that they do. These only study art, and these only study music. And these 4, they don't do anything, right? They're none of the above. Okay, so now looking at our notation, and I gave you a little mini Venn diagram underneath each of these just so we can visualize what we're trying to hone in on. So this first one here is saying only music, right? So we're looking at here the probability that this person studies music, right? All of the music. So it could be these 2 that only study music. It could be this one who studies music and French, this one that studies all 3 of these things, or these 3 that study music and art. So we're saying anyone who studies music. It doesn't matter if it's just music or if it's music and something else. So I'm looking at these guys right in here, this whole region, anyone who studies music. So if I add those up, I see that there are 7 of them out of 21 total. And then I reduce it, right? I have a 1 in 3 chance of picking someone at random who studies music. Okay, next one here, we're saying the complement of them studying art. So they do not study art. So I'm looking at this circle here, and I'm really keeping out of it, right? I'm looking for anyone else. They can study anything. They just can't study art. All right, so I'm looking at anything in that other space, just not in the art space. So I could add up all of these numbers and divide by 21, or I can go through the complement, and that's usually what I do. So 1 minus anyone who does study art would be 11 out of 21, and I get 10 out of 21. Okay, so next I'm seeing that fancy notation. I'm seeing that it is an intersection. So here we're looking at where art intersects with French. So here's my art, here's my French. I'm looking at this region right here. Here are all of my individuals who study French and art. We know that here would be those that only study French and art, but this one also studies music, right? But here we're looking at anyone who studies these two subjects specifically. So 2 out of 21 were reduced, okay? And then down below, we're seeing, okay, music, art, and French. Where do all of those intersect? And that's that sweet spot right in the middle. Right, here's where we're saying yes to all three things. So we see that there's only one person out of 21. Okay, next we're saying not music, not art, not French. Where do all of those overlap? Right, so it can't be music, can't be art, can't be French either. So we're blocked out of all of those circular regions. So we're in that outside space over in here. So we're looking at these 4 that exist in this outside space right here. Okay, so we're looking at the 4 out of 21. And then lastly, we see a union notation where we're saying, well, they could study music, or they could study art, or they could study French, right? They could study one of these things, 2 of these things, 3 of these things. So here, I see that that's going to be anything that's in any of these circular spaces. So again, I could add them up, right? I could add up all those individual parts, or I could go through the complement and remove these 4 that do none of these things. I would probably go that way. I like to be efficient. So 1 minus 4 over 21 gets me 17 out of 21. Okay, let's flip a page. Let's do the last example. It's really just making sure that we can build it. Can we build a Venn diagram? And then answer a few questions that follow as well. All right, so here a survey was taken to find out what newspapers people read. The results of 150 respondents are listed below. Make a Venn diagram to display the sample space, and then again, if we pick one respondent at random, calculate each probability, shade the appropriate part of the Venn diagram. Okay, so we're looking at reading newspapers, A, B, and C. That part is pretty self-explanatory. So here we're given some information and we have to build it. So here if I'm looking at 10 read all 3 of these things, that part goes right here. There's my 10. Okay, 24 read A and B. So here's my A and B. This whole part has to sum to 24. Since I already have 10 right here, then I have 14 right here. 36 read A and C, so this whole region here has to add up to 20 or to 36. So since this is already 10, then this part right here must be 26. Got ahead of myself there. So 26 plus 10, right, that makes up that 36 total. B and C, so right here, this part has to sum to 28. I already have 10 right here, so I must have the remaining 18 right in that spot. Okay, 72 read A. So everything in this circle has to add up to 72. So if I take 72 and I subtract that 14, 10, and 26, I'm left with 22 in this space. Okay, 62 makes up B, so this entire space must be 62. Again, remove these 3 numbers, and I'm left with 20 over here. And then 80 reads C, so this entire space has to add to 80. So 80 minus these 3 numbers, I'm left with 26. Okay, remember that we have 150 total respondents. I'm going to mark that off to the side. So I know that I also have the scenario that maybe we have someone who doesn't read any of these 3 papers. So if I take 150 and I subtract all of these numbers in any part of these circles, I'm left with 14 in this space here. So what's nice about seeing it this way now is that I can see that this 10 right here, they do all 3 things. They read all 3 newspapers. Anything here, 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 they read exactly 2 newspapers. Here, here, and here, they read exactly 1 newspaper. And this 14, they don't read any of them. They read 0 of them. So now I'm going to mark my little mini diagrams below with those figures just really quickly, because I want to show you the shaded parts when we are solving for each probability. So I'm going to quickly just fill in each of these numbers from that original diagram so you guys can see them as we work through these problems, and I'll go as fast as I can. Okay, so I'm ready to continue. So my next part here, I'm saying find the probability that we're picking someone who reads only A. So that means only A, nothing else. So the only A would be right in here, right? We're not including those that read the other magazines too. We want only A. So we want that region right there. So 22 out of 150 gets us 11 out of 75. We're good. Remember that these guys here read A and B, here A, B, C, and here A and C. We wanted A only, that space right here. Okay, next we're saying less than 2. So less than 2 would mean 0 or 1. So my 0 would be the space right here, right? These guys, they read none. Right here, here, and here, they read exactly 1. So I'm just keeping out of this space in the middle, but I'm really shading everything else, right? Anything that means 0 or 1. I'm just keeping out of that space in the middle. This is the artist in me that likes it well framed and still likes it to look pretty. All right, so there we go. So here, again, I can add up the 0, exactly 1, exactly 1, exactly 1. So if I add up those numbers, I'm adding up the 14, the 22, the 20, the 26, and that's going to get me 82. I take that 82, I divide by the 150 total, I reduce it down, so 41 over 75. All right, 2 more, and we'll call it a day. All right, those that read none, right, that's essentially saying 0. So any part that's outside of those circles. So I'm looking at this region, that 14, right, pretty clear cut. That's our none of the above region, right, the 14. It's in this space right here. Okay, this 14, they don't read any of these options. No to all things. So I'm looking at 14 over 150. So I get 7 out of 75. Okay, and then lastly, at least 2 papers. So that means 2 or more, which in this case means 2 or 3. Okay, so 2 or more, 2 or 3. So here we're looking at those that read exactly 2 would be in these 3 spaces. This 10 reads all 3. So I'm scooping up these guys in that middle portion. Okay, so I'm going to add up those that read exactly 2. So the 14, the 18, the 26, and those that read all 3, that 10, gets me to 68. 68 divided by 150 gets me 34 out of 75. Okay, that's our final answer. We could have also done 1 minus the complement. So since we solved for that actually directly above it, right, that would be the other way to go through it. So I could have done 1 minus the probability of 0 or 1 right here. That would get me the same answer in the end. All right, that's all I got. Have a good rest of your day.